Can you all see my?
Yep, your screen looks good.
Thank you. Okay, well, thanks everyone for joining today. So I'm going to give a high-level overview about a project that's just wrapping up called Pangeo ML. So this is an Axis 19 project that's focused on building open source tools and pipelines for scalable machine learning using NASA Earth observation data. Let's see. There we go. So this is a really collaborative effort. It's involved many more people than that are on the slide here, but the current list of co-Is include myself, Ryan Abernathy, Dave Hayes, Jim Bednar, and Martin Durant. And together, we've been working on improving the interoperability of the scientific Python ecosystem. So this includes Pangeo, PyTroll, as well as machine learning libraries. Developing new software interfaces connecting X-ray and machine learning libraries. So we're primarily doing this through XPatcher, expanding documentation around scalable machine learning in the earth sciences, as well as continuing to improve, maintain, and support Pangeo and PyTroll software. So all of these goals fit together to try to make the transition between exploratory data analysis and machine learning applications as seamless as possible. So many of you have maybe seen this slide before. It's the general orbit of software packages within the scientific Python ecosystem. All of these fit together to enable our science. And as part of Pangeo ML, we've had the great opportunity to contribute to the support of many of these. In particular, ZAR, X-Ray, and Dask through both some development time and also through community outreach activities. We've also been able to have targeted development towards many different software libraries that fit together to enable these machine learning workflows. So this includes packages like Intake, FSpec, Kerchunk, as well as the PyTroll and HoloViz set of tools and XPatcher. So in the remaining slides, I'll go over some of the key details of what's been implemented for each of these libraries. So the goal here is to get you to know where to look to find some of this new functionality that you can use in your work. It's not going to show it in any great amount of details, but it's, I think, a good starting point for everyone. And then the last part of the project has been tying all these tools together into a few science applications that we can also use to create documentation that will guide other people's science and applications of these workflow patterns. So to get started, Martin Durant has been leading a lot of really great work on intake. And the key takeaway from this component is that intake Take 2 version 2.0 is out and you should try it. It has the great features of separating out the data and reader concepts, removes the dependence on Dask, making room for more flexible compute engines. It also adds a bunch of helper functions, generalizes pipelining, and you can read a lot more about it in the blog post that Martin put out. So I will put these slides on the Pangeo discourse post, and all of these are links so you can read more afterwards. Martin has also been leading a lot of new features and bug fixes inside of FSpec. So a subset of that includes these new backends, generalized callbacks. I think the anywhere to anywhere bulk transfers using rsync is particularly exciting. And then we'll get more into this reference file system implementation in talking about Kerchunk. So a lot of the early work on Kerchunk was funded as part of Pangeo ML. Martin proposed some very key features that will improve this library for efficient access to data stored in archival file formats. So those include the Parquet binary storage format, which reduces the size of the reference files relative to JSON. Also adding a very highly desired append workflow for incremental updates. We created a X-ray backend for reading these. And we've done some preliminary work on generating coordinates for geotip reference data sets. I want to highlight that this is, while this work and Pangeo ML allowed some of these features, there's a lot more that's happening with Kerchunk right now, especially around the community organization. So I'd encourage you all to check out Tom's showcase talk from a few weeks ago, as well as all the discussions Martin has been leading on the Pangeo discourse and GitHub. There's a lot of areas to get involved in this project right now, and it's going to be a really high impact area of expansion. Jim Bednar's team has, through this project, implemented a lot of improvements to the HoloViz suite of tools, which is a coordinated set of libraries providing simple and powerful multidimensional data visualization and exploration tools. So more specifically, HBplot has even better interactivity for multidimensional data sets with automatic time and feature sliders. There's now server-side rendering and supported for distributed Dask data frames and arrays. And then within this other specific packages within HoloViz, there's a lot of updates to geoscience and PyData ecosystem compatibility. The improvements in handling tile sets and in particular some offline tile source usage and GeoViews is very cool. HVplot improvements include no code graphical interface, better interactivity with X-ray and pandas data objects, automatic rasterization improves our support. I really can't highlight enough how prolific Jim's team has been in bug fixes and features throughout a really broad set of tools that fit together really well for visualization needs. And the list really goes on. So there's data shader improvements, HoloViews improvements. Would definitely encourage you to check out this link to the HoloViz new GeoFocus tutorial. And a lot of these are described at a higher level, focused on applications and a few new cookbooks within the Project Pythia organization. So again, the links are all here. Moving on to some of the really exciting work that Dave Hayes has led. He's been working on the PyTroll project, which is an international community creating tools for working with Earth observation satellite data. So that includes SatPy, which provides reading, resampling, compositive, and writing utilities for remote sensing data. PyResample provides really great resampling utilities, and GeoXarray is this new library that aims at simplifying the workflows involving geographic data in X-ray. So a lot of the goals within SatPy were focused around optimized Dask usage. So that included a lot of memory and CPU utilization optimizations. There was also improved compatibility that was implemented between SatPy and X-Array and DataTree. And there's a new intake SatPy driver package that you can check out for loading data sets into SatPy. PyResample is very cool. In particular, I would really strongly encourage you to check out this new resample blocks utility that Dave's team implemented. It allows Dask distributed resampling of chunked arrays from one CRS to another, which is pretty exciting. Currently, it works on Dask arrays, but I've been trying out a simple wrapper into X-ray datasets, and it is pretty seamless. And that's just one of the many features that they've implemented in their progress towards PyResample 2.0, which will really simplify the geometry objects, update the documentation, and even in the existing versions of PyResample, there's improved compatibility with X-Array. And then GeoXarray is, in my opinion, another really great space where people could get involved. So it's really started the work towards handling CRS dimensions for geographic data a little bit better when working with X-ray data objects, but there's still a lot of room for really high impact features in this package. So I'd encourage you all to reach out to Dave to see what could be done here. As I mentioned, one of the core goals of this project was to improve the transition between working with exploratory data analysis and X-ray to plugging it into machine learning libraries. And the tool we've developed to do this is XBatcher. So XBatcher generates batches from X-ray data sets that then can be fed into models in TensorFlow or PyTorch. So there's a suite of features we've implemented in XBatcher to support this. First of all, a simple accessor interface for X-Array. We've implemented new TensorFlow and PyTorch data loaders, provided a pluggable cache mechanism that leverages ZAR. And I want to acknowledge the great work Megan and others have done on GPU computations. It was great collaborating on some of the SciPy and other blog posts like outreach activities related to this work. And uh, all of these have tied together into a set of science applications. And we've also used external applications like Zenthi and numerical weather prediction to inform our development. Um, One of these, which I think it would be great related to Xbatcher, a strong recommendation to check out is Joe Hammond's talk a few weeks to months ago on optimizing Xbatcher by prefetching data. So that is a past Pangeo showcase. I'll just go over a couple of these now. And so one of the climate or science applications that tied together a lot of these tools, including Xbatcher, was our climate downscaling project at Carbon Plan. So as part of this project, we developed utilities within Scikit Downscale for climate downscaling. We deployed multiple models using CMIP6 or multiple downscaling models using CMIP6 and reanalysis data. And I really encourage people to take a look at the map tool in particular, where you can interactively explore some of the downscale data products that came out of this project. Another related science application is the extreme heat work that Oriana Chegwedin led at Carbon Plan. So this developed a new data set modeling impacts of humid heat. There's a few different places where you can learn more about this. There's the data focused story on the Washington Post. We also have hosted at Carbon Plan an explainer article, and all the code, as always, is public on and open sourced on GitHub. And Raphael Hagen, who's here, put out a blog post as well, showing how we could speed it up even more using Kerchunk to generate the reference files for the entire NASA Next GDDP data catalog. So that that set of reference files are also publicly accessible if people ever want to use them in their own analyses. Ryan Abernathy's group has been working on machine learning applications related to deriving ocean currents. One of the outputs from this that y'all can check out is a Pythia cookbook on using Xbatcher in CNNs, which is on the Pythia organization. And there's also more work on doing a graph neural network that's ongoing. And the last component of this that I'll mention, which was really fun, was some of the community building involved in Pangeo ML. So as an example, I was able to organize a hackathon after AMS a couple years ago, which was a great opportunity for people to get together and share ideas or strategies. A lot of it was focused on machine learning. For example, we did have an Xbatcher related breakout group, but there was a lot of other great topics that were discussed at that event. And another avenue of more asynchronous community buildings includes our contributions to the Pythia ecosystem. So I'd encourage you to, for example, check out Andrew's cookbook on web map and feature services, or Raphael's cookbook on Kerchunk. As I mentioned, this has involved a lot of people, so I put probably non-exhausted list of their pictures here, but thank you to everyone, both internally to the project and externally, who has contributed to our efforts here. I think it's amazing that NASA is funding work like this, especially work that includes the fundamental support of existing open source tools. That is really key for science across the board. And many of these ideas were from early days in Pangeo. So thank you to the whole community. And also I want to mention Joe and Tom were both, Tom Augsburger were both early PIs on this project. So I want to thank them in particular for their ideas here. And that is 15 minutes. So thank you all for joining today.
Wow, awesome. I'm going to stop the recording.